Bye-bye music before I get another copyright strike against me. Woo! What's up, everybody? How are we doing today? It's the host with the most. It's your boy, the number one, the Ayatollah of rock and roller. It's Joe. Woo! All right, everybody. How are we doing tonight? I hope everybody's safe and warm. Got some hot chocolate, baby. Today was a nice cold day. I know we got about 1.5 feet of snow. I'm curious how everybody else panned out during the storm. I know we got some snow over here. Well, like I promised, like I said, today, ooh, come on, you crazy light. Today, like I said, everybody, we're going to be reviewing part 1, part 2, and part 3 today. Hope you guys like my new background. That was pretty fun to make today, actually. Been messing around in After Effects. I love it. I love it. I'm getting better at my Photoshop. And so I was like, let me crack open After Effects and see if I can figure this thing out. And it looks pretty cool, doesn't it? I gotta add some noise to it. I'll add some noise to it eventually. Maybe some more effects. Let me see if I can catch it. Come back in. Oh! Oh! Tastes good. I'm a goofball tonight, guys. All right, let's get serious. This is about serious and studying. All right. So, like I said, tonight though, we're gonna be jumping into I guess, yeah. So we're gonna do exactly what we did last Friday, even though today's Thursday. We're gonna do exactly what we did last Friday, where we'll crack open the Pearson test software there, and we'll go through part 1, part 2, and part 3, full exam. So it'll be full. So we'll probably be getting a pretty sizely exam test out of it. We'll probably get upwards. I'm hoping to get at least 75 questions out of this one this time, maybe 100 questions. So it should take us some time to actually go through it all. But I feel as though as long as we continue to do that, that knowledge will stick with us as we continue on and stuff like that. And then after we get through the exam, again, depending on how well we did, we may have to do it all over again. All right. So if I don't feel as though we did well, right, we're just gonna have to do it all over again. Again, I know it stinks that it doesn't give us different questions every time. I wish it really did. I wish there was a way for me to randomize it, but I guess there isn't. But that's fine. Whatevs. You know that those questions themselves, they're pretty good anyways to keep our minds on track of each subject and in each particular section there. So that's cool. And then from there, like I said, we're gonna jump over to Cisco Modeling Lab. We'll do some labs and stuff like that tonight. And then like I said to everybody, tonight will be the night. Tonight will be the night that if you are interested in downloading Cisco Packet Tracer, you have any questions about that, I will definitely, I'll be more than happy to try to get you guys to get Cisco Packet Tracer downloaded and stuff like that. Mainly, if you're using Windows, it'd be easy for me to explain that, and possibly Mac. If you're using Linux gets a little weird, gets a little goofy to download Cisco Packet Tracer. I've done it. But again, depending on what version of Linux you get, I mean, I can get lost in the weeds with it. It is available for Linux, and there are a lot of great videos on how to do it. David Bumble always, he's my number one guy to go through when I ever have a question for anything. Like I keep telling you guys, I'm in training for all this, guys. I am not I hope I'm not coming off as an expert to you guys or anything like that. I'm in training, just like you guys are. You guys are sitting along this. You guys are taking this ride with me. All right. And that's what this whole stream's about. This is a study stream. All right. This is for me, and this is for you too, guys. All right. I'm hoping though, so I'm hoping with the way though I try to explain things, just because of how, from my military background and my leadership background, I have a way of explaining things and saying things sometimes that I sometimes able to get information through to people in a different type of way. And that's all I'm hoping to try to do, just to help out those who are, taking the same footsteps as I am, and that goes out to you, all you vets out there too. If you guys are interested in jumping into the IT field, stuff like that, this is the CCNA is a good starting point into all that, guys, and I'm gonna continue to reiterate that 1,001 times. A lot of people have asked me, why do you feel as though the CCNA certification is so important? Why do you, overdoing other things? I'm in school to get a bachelor's degree too in information technology. I'm not just, my, where I'm aiming high. All right, I'm aiming high, for where I want to be. I want to be a network engineer. That's where I tend to be. I'm taking from the CCNA, we're gonna go right into CCNP. Well, we're gonna do CCNA, we're gonna do DevNet, then CCNP, then continue on to CCIE, and continue going on from there. I want the whole full battle rattle. When I lay down my resume, because I've already been laying out my resume to people, and I've been, again, I'm not an expert, but I have junior knowledge. I would have to say by now at least. I can configure routers, switches, and voice over. I can do all that stuff now. And I've had a lot of people already, like, I've had a lot of employers and stuff like that, just not even give me a second look. Kind of discouraging, honestly. But that just goes to show you, why you need certifications, I guess. You know what I'm saying? They still, if you look on a lot of their stuff, they still mention CCNA as being a certification that they look for. That goes with comp TA and stuff like that, comp security. Those are other certifications too that we'll probably be diving into too. Because those have value too. Those, it's like when people question about certifications and they question how much they should be able to make off it, you should look at yourself and say, what can you actually learn by taking the time to delve into the studies of that particular certification? Because you're going to learn something. No matter what, you're going to learn something, I guarantee it, by just taking the time to study for that particular certification. You're going to walk away with that much more knowledge. The Red Hat Enterprise Linux certification, that's a great certification. That is one that I am definitely going to have to do an undertaking on. Just because Linux and all these things they're so intertwined now. They're so important to one another, that it would be the I guess the logically next move. It would be the best move. Shoot, I got my my vSphere book, all about becoming a what is the terminology? I think it's like it's like a virtual architect. It's like a virtual architect type certification where you create. You got to create a whole type. You got to create pretty much a man. I'm like smaller with my words, but it's like you got to create a multiple layer topology, that involves clusters and build your own. It's just you're creating your own infrastructure. There we go. So create your own infrastructure inside of a vSphere, a vCenter cluster. You know what I'm saying? And again, I'm just dabbling. I'm just dabbling on that right now. But I already got my EXXI. these are things that I spend a lot of time in trying to study, um, and trying to become more efficient and more fluent at. Just because, again, the value in these, the value in these certifications, the value in knowing what these things do, knowing how to manage them, knowing how to um, get them to pretty much do what you want them to do for you. You know what I'm saying? It's one thing to have a EXXI server. It's another thing to actually know how to use that EXXI server. Again, it's one thing to use VirtualBox and actually know how to do everything inside of VirtualBox. Uh, even VirtualBox. There's a lot of cool tools in VirtualBox. I used VirtualBox in the beginning of this journey, but I slowly stepped away from there because of the direction that I wanted to go into. Obviously, I wanted to look at more of the corporate enterprise and what are they using. You know what I'm saying? I don't take anything. I'm not taking anything away from VirtualBox. There's probably enterprises that use VirtualBox. There's probably enterprises that use Proxmox and stuff like that. But when it comes to licensing and stuff like that, I wanted to make sure that I was using the products, using the software that big companies would most likely be using. That network engineer on the higher tier level would be using, or even the junior tier would be using, and having to know how to make, VLANs inside of EXXI and build, virtual switches and stuff like that, and set priority groups inside of EXXI and how to make that work, and how to then how to utilize vMotion to its fullest capacity. vMotion is something cool, guys. I can't wait to really spend some time using vMotion. I need to just beef up my little setup that I got. My setup's small. My setup can do a lot though. Boy, I tell you, when I talk to some people about the kind of setup I got, they're surprised at the things I can do with my setup. But I still need to do a little bit. It needs a little bit more to take it to that real next level where I could, be hosting. No, I can do it right now if I wanted to. I can host multiple instances of EXXI and have vCenter up, but it wouldn't be working the way I want it to work. You know what I'm saying? I could do it, but I just wouldn't have it be as efficient as I want it to be as efficient. That just goes, I guess, with anything. vCenter is another thing. Again, I just have to get around to really making sure that my bolts and my screws are tightened a little bit tighter on my on the stuff that I'm using, and that I really know what I'm using before I start breaking stuff. I've already locked this computer up several times since I began my journey into all this stuff. It's been a fun journey though, guys. I mean, from man, like I said, I think it was about back in August that I actually got around when I first built this computer. And you can believe me or not, but this was actually the first computer I've actually truly owned. You know what I'm saying? Yeah, I've messed with computers and I was a manager for a long, for quite some time, and I had to know how to, get around computers. But did I ever really know what I was doing on them? No. But I just have this way of confidence though that I want, I guess I spew confidence onto what I do, and I just try to just dive into it, and I want to know what I'm doing. Instead of just assuming what I'm doing is the right thing, I want to actually know what it is doing so I can understand wholeheartedly that I'm doing it correctly. That's just been my approach. That was my approach when I was an equipment operator. I wanted to know that equipment. I was the guy that was out there running around the equipment, making sure, doing all the pre-checks and checking the oils. When I was a dump truck driver, I was I would always blow away my boss by always checking the oils and transmission fluids and checking the hubs and checking the ties and, checking the drive shaft, making sure the hydraulics work before I even left the garage. that's just the kind of person I was. Same thing when I was an equipment operator. Same thing. I worked, I worked a long time in a junkyard, and I had the cleanest loader in the whole entire yard. You can eat off of my loader. I would power wash that thing every night. Even on my own time, I would power wash it, just to ensure that the next day when I jumped in that thing, because that's what made me my money, and that's what made the company money, was that machine working. So I needed to ensure that it worked properly. I take that same approach to what I do now. With that kind of intensity and that kind of drive I want to make sure that I'm doing it right. That's why I built this computer with my bare hands, because I wanted to know what it was to get into it and know everything else. And that's the kind of approach that I take with the CCNA stuff. And that's just what I hope that comes across as you guys are joining me on this journey. I hope in the near future, as to make this a more entertaining channel, more entertaining approach to how I do this. I'm learning still how to do all this streaming too. But I don't take a day off. As you guys tell, well, if you guys have been joining me since I started, you've seen I hope you guys can tell that I've tried my best to make improvements on a daily basis to how I stream, how my content is looking, and stuff like that. Because I guess I'm a perfectionist. I might not know everything, but if I want to know it, I'm gonna do everything I can to make sure I know it well, and that I'm doing it to the best of my ability. So, take that for what it's worth. So, this was fun to make though. This got a lot of laughs today. I wanted to make him have a little noise. I still might do that to annoy everybody, but it's fun. All right, let me get off my tangent, my soapbox. I love my soapbox. It's full of Dove soap. It smells so crispy clean. All right, goofball. Let's dive into what we're doing tonight, guys. All right. Let's go over to the big test. All right, so use my new controller. It's my cell phone. All right. Cool. Transitioned. Perfect transition. All right, everybody. Let's get busy. I swear I'm going to lose my voice here soon. I talk so much. That's the whole point. All right. Let me get my markers ready. Grab my eraser. My eraser's right here. Give me my eraser. All right. Got my eraser. No, I should have done. I should have grabbed another black marker, but I didn't grab one already. It's fine. All right. Let's get ready to rumble. Oh, don't want to get copyright strike on that one either. I swear, guys, I've been getting copyright strike like crazy. I don't know what it is. It's all that, and I use the free. I try to do my best. I don't use anybody's music. I use the free, the free music that you get from YouTube. That's supposed to be uncopyrighted and what. Boy, I tell you, they still light me up like a Christmas tree. That's why I stopped playing music altogether. But it's fine. I mean, I guess music's really not part of what we should be doing here, but it gives it a little subtlety. That's fine. That's cool. It's all good, baby. Not trying to rip anybody off. All right. What do we got? All right. So we got Chapter 1, Introduction to TCP Networking. Chapter 2, Fundamental of Ethernet LANs. Chapter 3, fundamentals of WANs, all right, wide area networks and IP routing. Chapter 4, using the command line interface. Chapter 5, analyzing Ethernet LAN switching. Chapter 6, configuring basic switch management. Chapter 7, configuring and verifying switch interfaces. Chapter 8, implementing Ethernet virtual LANs. Chapter 9, spanning tree protocol concepts. And Chapter 10, this is what we reviewed last night, RSTP and Ethernet channel configurations. That is going to be, that one right there, boy, I guarantee it's going to beat me up tonight when we get into that chapter. All right, we're going to select all four. Let me grab my handy schmandy epic pen over here. And let me just make sure it works. All right. They did an update. A recent update just dropped for it, but the update that they previously had, I tell you, because they have it where it drops down here now, and yeah, it would just constantly break on me. Whatever, that's all good. All right, so let's get into it. Let's see how many questions. I'm curious to see how many questions. Ooh, 73. That's pretty good. That's pretty good. I wanted about 100, but 73 is good. This should take us some time. All right. And I helped some young lady who was stuck outside my street today. She was driving a little Honda Prius, and she was trying to get through the 1.5 feet of snow with her one-wheel drive Honda Prius, and of course she got stuck. And dude, there was like 3 or 4 plow guys that just looked at her and just drove right past her. You know, big old burly guys, and whoop, they just drove right past her. So, you know, I ran outside and, you know, grabbed my shovel and did what I could. And I got her out, and I, you know, sent her on her way. She was very thankful. But I tell you, I felt like I got, you know, hit with some really cold air, man. My stinking throat ever since then has been all messed up. All right, enough of that. All right, which of the following terms represent layer 3 PDUs in the OSI model, which includes the network layer header and encapsulated data? So, which of the following layer 3 PDUs in the OSI model represent the network layer? So it's given us a couple hints. All right. So first hint we got is network. Second hint we got is layer 3. So remember, we have the physical, we have the data, okay, and then we have the network. All right. So the physical, that's the actual wires. That's the actual physical bits that are running through the wires. Then we have the data, that's the frames, okay, that's the frames, that's the MAC addresses. Then we have the third layer, which is the network, which is IP packets, okay, packets. Let's go with packets. Ooh, gotta get my thingy out. Let's go with packets. All right, next question. The term segment refers to which layer PDU? All right, so again, we got bits, we got frame, we got packets, and then we get up to the TCP UDP level, okay, the transportation level. That level deals in segments, okay? So that's the transport. All right. All right. The output from the network analyst tool, it lists a group of lines for each header in the PDU with the frame data link header at the top. Then the next header, typically the IP header, and so on. The first line in each section has a gray highlight with the indented line below each header line listing details about the field inside the respective headers. You will need to remember some part of the various headers and compare those concepts to this output to answer the question. Okay, so based on the packet capture shown, which of the following is true? All right, so we have, so it's given us, it's not asking us a question, it just wants to know which one is true. So we have A, all right, this is the data, this is the MAC addresses, okay? So we got B, where this is IPv4, this is dealing with the network packets, okay? This is TCP UDP, this is transmission, okay? And then it's just saying telnet, this is the application level. Okay, all right. Line C, nope, that's not it. That's dealing that's segment, that's transportation. Line D is used to connect this tablet. Line D is used for the connection establishment and termination flow of segments. Nope. All right. Line A is used for logical addressing, routing, and path determination. Line C is the transportation. Yes, it is. And the TCP model. And what is line B? Internet. IP. No. Okay. It's only asking for 1, 2. Remember, you guys got to catch me when sometimes it asks us for more than 1 or 2 questions at a time. Sometimes I miss that. Bugs me. All right. But that's the same kind of things that's going to happen on the actual CCNA certification test too as well. So that's the reason why I continue to take this. All right. IP functions at what layer of the OSI model? Okay. Remember, we got physical, data, network, IP. All right. The output, so same thing. So let's just read the question on this one. In describing line A from the graphic with an OSI model perspective, which of the following, which is the correct label to be used in combination with that PDU? So in describing line A is the data, the MAC addresses, okay? So let's take a look. So it's the datagram. Oh, I can't believe I did that. I can't believe I did that. I'm going too fast, guys. I didn't have enough coffee already. I'm gonna blame it on the coffee. That was a rookie mistake, Joe. Okay, a user has sent a request to the server. Which process does the server datagram? I can't believe I said datagram. That's gonna bug me now. Which of the I might have to do this whole test just because of that one. Which of the process does the server go through to determine what service is being requested by the user? Okay, the user has sent a request to the server. Which process does the server go through to determine what service is being requested by the user? So it is de-encapsulation. Yeah, it's de-encapsulation because it opens up the server. The user sends a request to the server. Which of the process does the server go through to determine what service? Let's go with de-encapsulation. Okay, de-encapsulation. It's opening up that packet, de-encapsulating that packet. All right. The diagram shows a simple internetwork in which all LANs connections use fast Ethernet. Select the answers for the correct cables. Now remember, when we're dealing with PCs, routers, and access points. Those have the same logic. Switch, bridges, hubs have the same logic. A PC to a switch, that's straight through cable, but a switch to a switch or a switch to a bridge, that's crossover cable. Okay, all right. So we have to select 2. So a crossover cable between and Ethernet crossover, nope. A rollover, nope. And an Ethernet crossover to the switch to the hub, yep. All right. Remember the wider diagram in the core for the fiber optics. That's multi-mode, because remember that light in the multi-mode is bouncing. Okay, single core. That's when the core is really, really small, so that light is forced to shoot in a straight line. All right. From the output of R1, which of the following is accurate? Okay. So, okay. R1 has learned about the IP addresses of R1. No. The address of is designated to be assigned into a single, never to be duplicated. That's kind of right. R1 uses the address. Nope. And nope. Okay. So the address of the MAC address obviously is designed to be assigned to a single NIC interface card. All right, NIC network interface card, and never duplicated on a different NIC. All right. All right. In the figure, Cat5 cabling RJ45 connections is used. Which of the following statements are true about the wires inside of the RJ45? So again, this is just going over that crossover straight through type cabling. This is just cabling questions, okay? So what do we got? How many do we have to choose? Is it just a one question? I'm not seeing multi. All right, so it's just asking for one correct answer. All right, I hope so. All right, the cable from PC1, nope. S1, nope. PC, yep, so it's that one. All right, further the diagram, the new connections the new connections that's going between the campus 1 and campus 2 routers is required to provide at least 500 megabytes per second bandwidth. The routers are located 3,000 meters away from each other. What standard of Ethernet should be used in this situation? So remember, when you're dealing with big numbers and big distances, so just so we can just try to keep this in our memory, big numbers and big distances, we're going to go Zulu. We're going to go Zulu. So we're always going to think Zulu. So the 802.3 Zulu, okay? All right. The network in the figure uses Cat5 cabling. Which of the following statements are true about the wires inside the cable? So it's just another cabling question, and let's make sure. So we got to select two answers. All right. So the cable from S2 to S1 is on pin. Yep. So that one's right. We just gotta get one more right. That one's wrong. Nope. That one's wrong. And that one's wrong. And this one is right. Because so pin 1 on the crossover, it's pin 1 to pin 3, and then pin 2 to pin 6. All right. All right. Another Anna is just grabbing another packet. The circle-filled part of the Ethernet header lists the value of the hex 0800, which in this case means the IP header follows next as shown on the line below. What is the type? So that's the type. Okay, that's just the type. What fields are in an IPv4 header? Okay, so that's protocol, time to live, and all right, DS. All right. A device uses MAC address 000C42B946EE. Which part of the MAC address indicates the originating network vendor number? All right, so that's the first half, guys. So that's the first half. So that'd be the 00 Charlie 42. All right. All right, here's another cabling question. Okay, we got to choose 3 on this one. Let's make sure we got this right. All right, so the cable from S2 to S1 is on. Nope, we can already count that one out. This one's right, straight through. Yep, and that one's wrong. That one's wrong. Pin 1 and pin 3, yep, on the 2 switches, and then that one's right. Okay. All right, a lease line provides what service? This one used to stump me. So a lease line, it's a physical line. A lease line is a physical line. So we are back on the layer 1 of the OSI or the TCP/IP model. Okay, so a lease line is a physical line. So when we think in physical, we think layer 1. Okay. All right. Which answer lists an Ethernet-based wide area network service? So which one lists a wide area network service? And Ethernet over MPLS, and then Ethernet E-line. Okay. All right. Based on the diagram, host A sends a packet to server B. The 2 serial links use HDLC, while the rest are Ethernet. How many times does the packet experience de-encapsulation? All right. So again, every time, what happens is when these packets hit this interface right here, it's going to be de-encapsulated. Okay. All right. So it's going to be de-encapsulated, and then remember, it's going to pick up this actual interface's MAC address, because this NIC. This network interface card on this interface is picking it up. So it's 1, okay, 2, all right, 3, all right, 4, all right, and then 5 times, okay? All right, And the reason why I stated that is because I knew that we were going to be getting this one X next. And this one, again, this was another one that, again, used to kick my butt. We should be able to figure it out now, okay? In the figure, all devices statically configured with the IP address, mask, and default gateway information, assuming that all switches and PCs have just completed reloading. The switch MAC addresses are empty, the PC's ARP tables are empty, and none of the PCs or routers have sent a frame yet. Which of the following is true? So remember, nothing's been done yet in this network. Nothing has been flowing through the wire. Okay, so since nothing's been flowing through the wire, we have to think of some of these messages that are going to be going out. We're going to select two answers. All right. When PC1 pings PC2, its first Ethernet frame will have the bar0. Nope, because it doesn't even go to the router, so we can say no to that one. PC1 pings PC2. The first packet will be an ICMP echo. So that's doing the ping. So when you do the ping, that ping message just sends an ICMP request, and then obviously once the other host gets it, they send a reply back. But no, the first packet though will be an ARP. All right, it will be an ARP packet. All right, because remember, everything needs to know where everything is. All right. When PC1 pings PC2, the first Ethernet frame will have a broadcast address. It will, because it's going to be that ARP is going to be sending out to the FFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFfffffffff PC2, the first Ethernet frame will be an ARP request. Yes, it will. When PC1, PC2, the first Ethernet frame will have PC2's MAC address. No, because it doesn't know it yet. All right, that's what ARP is trying to figure out. ARP's trying to figure out all this stuff for us. All right. All right. A user at host 10.3.0.1 powers on a device and issues the ping 10.3.0.2 command. What is true about the ARP request sent by the host 10.0.3.1? All right. A user at the host powers on a device and pings. What is true about the ARP request? All right, we got to select 2. The frame will be de-encapsulated only by the device using. All right, the device processing the request will reply with a unicast frame. Yeah, I would say so. This is part of DNS. No. Host A is attempting to learn layer 2. Yes. Okay. All right, let's keep it moving. Which of the following data link layer protocols are used to encapsulate data on a leased line? So encapsulating data on a leased line. So we have HDLC and PPPP. All right. Which protocol finds unknown layer 2 addresses from known IP addresses? That's ARP again, guys. Okay. ARP finds unknown layer 2 addresses from known layer 2 addresses. Known layer 3 addresses. I apologize. All right. How does the receiver of a HDL frame know what has been encapsulated within the frame? All right, and that's in the type field header. All right. Using a cable connected to a work PC to the console port on a switch, you notice that the switch is not responsive. A coworker mentioned that the same PC was used in the same switch earlier that day. The SYST LED on the switch is green. Considering the given scenario, what should the technician do? Not a crossover. Verify the correct physical connections have been made. I would say so. Check to see if the all right, and it's a rollover. Okay. Okay. So when you're connecting up to the console port using a rollover cable, and obviously you want to verify that that actual connection has been made correctly. All right. Verify refer to the diagram. Which of the following connections parameters are used when connecting to the console of the Cisco switch? All right. So remember that's 9600, 8 and 1. 9600, 8 and 1. All right. If an engineer issues the copy running config static config, which Cisco memory type would the configuration be copied to? So remember, when you're in the actual switch or router, everything you're doing for that instance it's just being copied to RAM. But if you need to save it, you need to save it to the NVRAM, because the NVRAM is where it's going to hold that config for when it boots up. All right. So the running config is saved in RAM. The startup config is saved in NVRAM. All right. All right. When the Cisco iOS command line interface is initially accessed via console, telnet, or SSH with no privileges, which mode is the user placed in? So the first mode, that is the user mode. Okay, guys? All right. What is the name of the Cisco iOS command line interface exec command that allows a user to run more powerful commands? All right, so that's enable. If an engineer has completed a series of changes to a Cisco switch and wants to ensure that the changes are saved and retained across reboots, which command would the network engineer use? So that'd be the copy, running config, startup config. That one. Yep. Copy, running config. All right. Startup config. Next question. Your switch is in an air-conditioned, locked wiring closet on the first floor of a building. There is a card reader on the door that allows only authorized personnel into the room. On Thursday, you used Telnet to connect to the switch and issued the following command: hostname S1 and log out. Oh, cool. What did not do? Hostname S1 and log out. Cool. His hostname changed and everything. All right. The following Monday morning, you used Telnet into the switch and ran the show version command. You see the following. So what didn't he do, guys? He forgot to save the configuration to NVRAM. All right. What is the default aging time for a MAC address table entries that have not been used? So that's 300 seconds. All right. How does a switch build its MAC address table? Hello. Hold on one second, guys. I got a visitor. I got a feeling that somebody's watching me. Oh yeah, I can't do that. I'm gonna get another copyright strike. I'm gonna get me another copyright strike. No more copyright strikes. I can't even talk anymore. They're gonna copyright my voice now. Sorry, guys. I'll get off my tangents. All right. How does a switch build its MAC address table? Okay, by listening to incoming frames and examining the source MAC address. Ooh. By listening to incoming frames and examining the destination. Nope. By nope and nope. All right. So it's number one. By listening to incoming frames and examining the source MAC address. All right. In the figure, all devices are statically configured with IP addresses, masks, and default gateway information. Assuming all switches have learned the MAC addresses for all devices in the figure, PC1 pings PC4, and PC1 receives the reply, confirms that the ping worked. Which of the following are true about the frame sent through this network and their encapsulated packet? When considering a frame, consider the header of the frame and any encapsulated packet. So, where are we at? Johnny, where are we at? All right, I'll tell you, Joe. All right, so we're right here, and we're pinging right here. So, Mr. Bad Larry over here, got to go through a couple stages. He's got to go through all these switches, and then he's going to come down here to this switch, and then he's going to come back up here to this router to switch, and right there. Okay, so let's take a look at what we got. The frame that contains the ICP echo request sent by PC1 has this destination of yes, it does. Okay. The frame that contains the ICP echo sent by PC1 has the destination MAC address of PC. No, it doesn't. The frame that contains the ICP echo reply sent by PC4 has the destination MAC address of the FA0. No, it's going to have the FA01's MAC, not the 500s. All right. Frame that contains the ICMP request sent by PC1 has the destination MAC of the 50. So yes, it's going to be that one. All right, because it's going to come through. It's going to hit this NIC right here, so it's going to pick up this NIC's MAC address. All right, scroll down. The frame that contains the ICP echo request sent by PC1 has the destination. No, the frame that contains the ICP echo sent by the frame that contains the ICP echo sent by has the destination. No. All right. Which type of memory does the switch use to build the MAC address table? All right. Which type of memory does the switch use to build the MAC address table? So it's the TCAM. All right. All host switch ports reside in VLAN 1 with no port security nor static MAC addresses tables entries defined. Host B remains off, powered off, but all other hosts can ping each other successfully. Host B powers up and issues issues a ping to 10.1.1.4 command to generate host B's first network traffic, which answers all right, describe the frame forwarding scenario. So let's go back to my handy schmandy. So here's our host, here's our fellow with it all right here, Mr. Host B, and he's pinging Mr. Delta over here. Okay. So what's gonna happen to that frame? All right, host B hasn't pinged anybody. All right, so host B is going to be sending out its first message is going to be an ARP. Okay, what's an ARP? ARP uses the FFFFFFFF, that broadcast address. So not only is that frame going to be going this way, all right, that frame's going to be going here. It's going to be going out the switches. All right, it's going to go to everybody lottie dotty. Okay, everybody lottie dotty. All right, it's going to be coming over here to switch 3. Everybody lottie-dottie is going to get a copy of this one now. All right. All right. So with that logic being said, what are our answers? The frame will be forwarded out. Switch 2's gigabit 0-1 interface. Yes, it will. All right. The frame will be forwarded to switch 2, but now switch 3. Nope, it's going to switch 3. The frame will be forwarded to the host. Yes, it will. And it's going to go to host A. All right. Let me just erase mine. My beautiful art. All right. What is? Let me close this. It's gonna close up. What will a switch compare in its MAC address table, MAC table to be able to forward a frame? All right. So that's destination. All right. Destination MAC address, not source, not IP. So it doesn't even care about IP. All right. Source is just what it's going to be adding. So when a packet comes in through its gigabit 0-1 with the source MAC address of host B, that's what it's going to be adding to its MAC address table. But for forwarding purposes, it's going to be taking a look at that destination because it wants to know what interface does it need to send that frame back out of. Okay. All right. After power on, a frame arrives at a switch. The switch had not yet learnt the source MAC address of that frame. Which action must the switch take in that case? Let me read that one more time. After powering on, a frame arrives at a switch. The switch had not yet learned the source MAC address of that frame. Which action must the switch take in this case? So we only need one answer. The switch adds the Nope. The switch adds the source MAC address and destination. Nope. The switch adds the source. Yes. So again, switch logic. It adds the source MAC address to its MAC address table. Okay. All right. All IP addresses are configured for the PCs, and they are correctly connected to the network. The MAC address tables on the switches look like this. So here's our Mackie Macs, our Mac attacks. All right, so it looks like we have a couple different VLANs. We have VLAN 2. All right, VLAN 2 though is showing two actual hosts. Two two MAC addresses with some interfaces, and it looks like only VLAN 3 over here is actually only showing one actual MAC address and one interface. So we have a MAC address related to the 501, and then that's in host VLAN 2, and 502 VLAN 2, but the 504 is in VLAN 3. So let's scroll it down. So 504 is already in VLAN 3. Well, it's already been learned. All right. The output PC4 has the layer 2 address of PC3's and its ARP table. PC4 sends a unicast ping request to PC3 as shown in the packet capture. The output, yeah, okay. What will be the result of the ping request? What will be the result of the ping request? Let's just take a look. So obviously the switch though, the switch has not learned, all right, what's going on. So the switch will flood. It's not gonna, because this is in a different VLAN, it's not gonna flood it out to those PCs. The switch will filter the frame and not forward. Nope, it's gonna flood it. The switch will reply to the echo request and echo reply. No. It's gonna flood. The switch will flood the frame to PC3. So even though there's only one host over there, it's still gonna flood it to PC3. All right. In the figure, the 2960 switch has been taken out of the box and cabled. PC2 can communicate through router run the rest of the IP network. However, with the rest of the network. However, no configurations have been made to either switch 1 or switch 2. As a result, the network engineer sitting at the management station on the right of R1 cannot ping or telnet S2. Which of the following configuration commands were, when entered into the correct order on switch 2, allows the network engineer to ping or telnet the switch 2 for management. Now remember that switches work off of layer 2. All right. Now you don't need, switches do not need MAC. They don't need IP addresses to work. They don't need an IP address to forward frames. All right. IP packets, that's a router's job. Routers work at layer 3. All right, at the network level. Switches work at the layer 2. All right. We're still on the top. This is still on topic of layer 2 switches, L2 switches. Okay. But to ping one, to telnet into one, to SSH into one, you need to assign an IP address. Obviously, that's the only way you're going to be able to communicate with it. You need to assign an IP address to it on a VLAN, preferably the native VLAN or your management VLAN. You know, whatever VLAN you're going to make your management VLAN, and then you have to assign that VLAN to an interface. Okay. So we need 4 answers. Okay. And he's talking about switch 2. So switch 2 has this IP address. And what are we looking for? IP default gateways. Okay. We got to give it the no shut. And interface VLAN 1. And there's that one. All right. The exhibit shows some configuration commands that sit in a text file. After adding this configuration to a switch, the user will attempt to connect with the username Fred and password Hope. Which of the following best describes the accuracy of the configuration for allowing a user attached to subnet 10.1.1.0/24 to use SSH to connect to the switch? So let's take a look. So we have host name, that's good. We have IP domain at exhibit.com, that's good. They have the Fred and the password set, Fred and username and password set, cool. The crypto key generate RSA modulus 1024, very good. They get the VLAN 1 going. They assigned an IP address, very good. They give the no shot. They went into the line VTY now. Right here, guys. There's our problem. So they only gave it the login. So the login is not going to be able to recognize you got to use the login local command for it to use the password, the username password combination that you just set for it. Okay. They set up transportation for both Telnet and SSH. So, that's correct. That's correct. The login local, okay. The login local configuration was not set correctly. All right. An engineer logs into a device to perform some troubleshooting. The engineer expects the need to repeat many of the commands, so he wants to ensure that the device remembers the commands in the device history buffer for easy recall. Which command would be used to ensure this behavior? Okay. So we're in here. Terminal history and then history size. Yep. All right. All right. Which command would generate the SSH encryption key? So the crypto key generate. Yep. Crypto key generate RSA. Even though it's an SSH key, it's crypto key generate RSA. Crypto key generate RSA. Okay. All right. As an administrator, if you decide to change the password periodically on the switch, you enter the following command: enable password. The next time you telnet to the switch, you are prompt for the password, but Bubba is not accepted. Why? The enable password that was set was not set to the VT line. The enable secret password should have been changed instead. We should have been in line configuration mode. The telnet protocol. All right. So the administrator decides to change its password periodically. He gave it the enable password. Bubba. The next time you telnet into the switch, you are prompted, but Bubba does not work. Why? The enable password that was set is not in the VT line password. The enable secret password should have been set instead. We should have been in line configuration mode before using that. The telnet protocol is not allowed on VT. No. Enable password that was set is not in the line, the VTY, possibly. So is that one. So they didn't go into the line VTY sub interface and initially tell that line to use the login. So that'd be the login command that they should have been using, so that they can just use the password instead of the but they didn't do that command at all. So that's why that didn't work right there. All right. Which answer encrypts the password that will be required of a user after they type the enable exec command? So that'd be the so it's looking for an encrypted password. So that's the enable secret. So remember, enable secret encrypts the password. Okay. Enable password does the same thing, but it does not encrypt it. It still shows up. That password will still show up as clear text when you run your show run command. Okay. All right. A local user, Bob, has been created on the switch, and the following output is from the same switch. So a local user, Bob, has been created on the switch, and the following output is from the same switch. So show crypto key, my plug RSA. What do we got? So we got the domain name. Very good. Here's the RSA key, the SSH key. Yep. All right. Bob has an IP address on his computer, and he can ping the interface on the switch. SSH is enabled on the VTY lines, but the user Bob cannot log into SSH. What needs to be configured? So what needs to be configured is make Bob's, nope. Configure the domain name, nope. Require local login authentication, yes. So they didn't state that they were gonna use the local login parameter, so that needs to be authorized. Okay. All right. Which two of the following actions provide the best security for accessing a router? A router's privilege mode remotely. Which two following actions provide the best security to access routers mode? So that'd be the enable secret and enable. That'd be the SSH disabling telnet transport input just SSH. Okay. Refer to the diagram if auto negotiation of the speed and duplex between host B and the switch works. What should be the resulting speed and duplex? So host B, what should be the resulting speed and duplex? So to be 100 and full. All right. Refer to the diagram in the exhibit. Which of the options is potential reason for the interface status shown? For the Ethernet interface shown in the figure. Take a look at the figure. All right, what do we got? So we got some IP addresses. Cool. That one. This one's down. This one is up. No, it's down, down. So that's down, down. Doesn't have an IP address and nothing showed on it. On this, on R2, we have, so they're both actually down. The status is down. Okay. All right. All right. Mismatched interface speeds. Different sub. Ooh, let's take a look at that again. Oh, we have different subnets. All right, even though I can't see the either way, yeah, it's different subnets. There's no other way around it. I don't even have to see the subnet mask. It's definitely different subnets. All right, so we got different subnets for one. And what is it? And it's just showing the it's just giving us the down. Doesn't matter with the speeds, it's most likely a disconnected cable. Let's go with disconnected cable. Nope. Mismatched interface speeds. So that'll cause a problem then. Okay. So interface may be down state. A number of reasons include disconnected or bad cable or Oh, okay. I see what it's saying. So I got, yeah. Huh. Another one of those tricky questions there. All right. I'll take that. I'll take that hit. Let's move on to the next one. All right. We're doing actually pretty good, I think. All right. Refer to the exhibit. Based on the information shown in the exhibit, what can be said about the configuration of gigabit 0-4 interface? Let's take a look. Gigabit 0-4. So it is set at half and speed 100. So speed 100 and half duplex. Okay. All right. What are the common local area network layer 1 problem indicators? We got to choose two. Layer 1. Go with collisions and lake collisions. Cool. All right, refer to the diagram. If auto negotiation of this speed and duplex between host A and the switch fails, what would be the resulting speed, assuming sense failure in duplex. So what do we host A? So it'd be 1000 in full. Further the speed auto negotiation of the speed in duplex between host A and the switch fails. What would be the result? Oh, because it goes down to the slowest speeds. Is that what it does? When auto negotiation of both speed and duplex happen, two rules are followed. The slowest supported speed is used. Alright, you got me again. Alright, let's continue on. Refer to the diagram. Both switches are Cisco switches. What would be the state speed in duplex of the link referred on the switch SW1? So what do we got? Refer to the diagram. Both switches are Cisco switches. What state and speed in duplex of the links refer on the switch W1s? What do we got? So switch 2 is setting speed in duplex at 1000 in full. Let's go with the 1000 in full. All right. Refer to the diagram. Auto negotiation is enabled. What would be the resulting speed in duplex on the links between student auto negotiation? What are the following links between S1 and SB? So that's 100 in full. All right. Based on the figure, what Cisco iOS command would be used on switch 4's correctly configured interface 501 to be an access port in VLAN 30? Let's get my handy thingy. So we're looking for a switch 4. And we want VLAN 30 on 501. So switch port access, VLAN 30. Yep, that easy. That easy. You don't have to highlight anything. All right. In this network, all switches are powered on and all relevant VLANs have been configured correctly and are working. Based on the output in the exhibit, which of the following statements is true about S2? Let's look at S2. Take it with me. So here's S2 right here. Alright, shot. Oh, I love the small print. And what do we got? What do we got? So one VLAN, 24 fast Ethernet interfaces, 2 gigabit interfaces. All right, let's remember that. All right, so let's take a look at our. So we got VLAN 1. We do have a VLAN 5, but nothing's in it. All right, we're missing a couple of interfaces. 23, 20, 23, 20, 22, 23, and 24 are missing. All right. 3 interfaces are trunking. So on the show reports, the trunks will not show up. Remember that. All right. Which iOS command can be used to display which VLANs are supported over specific configured switch trunks? So that'd be the switch show interface trunk, right? I believe it's that one. Yep, show interface trunk. Okay. What are true about the command switch port negotiate? Right, switch port. Oh, non-negotiate. Switch port non-negotiate. Let me say that again. All right. If connected to a switch that uses dynamic and desirable, the switch won't truck. Nope. This command will cause DDP. Nope. This is on by default. Nope. This is used only when a router. Nope. Used to ping and prevent switch ports from being trunks. Okay. Pretty much. Oh, I got it wrong. Connect to the switch. Oh, man, I gotta read these things a little bit closer. Let me grab some water. I need some water in my life. All right, grab some water. All right, let me slap myself around a little bit. Wake up. All right. Refer to the exhibit and diagram to make it possible for all traffic to pass between PC1's local area network and PC2's local area network. The link between S1 and S2 will be configured as a trunk. The Cisco IOS command could be used on switch 1's gigabit 0-1's interface to force the active attempt to make a trunk. So that would be switch mode. No, the dynamic desirable. So remember, dynamic auto, that won't make a trunk. That won't force a trunk. Dynamic desirable will make a trunk. Okay. All right. RSTP serves as an improved protocol in comparison to the older STP. Which of the following answers list a feature of RSTP that does not exist in the STP? Okay, now we're in the realm of STP where we just were earlier. Okay, so the criteria switches that the criteria used by a switch to determine the designated ports on a segment. The criteria used by a non-root switch to be chosen for criteria used by a switch to be determining all ports to act as backup role. That's kind of it. Yeah. All right. So we're going to choose that one. Because remember, STP, it doesn't recognize backups and alternate ports. That's RSTP. Okay. RSTP recognizes alternate and backup ports. Okay. All right. Assuming all default STP settings, which of S3's ports will become its root port with giving the cost. Now remember, gigabit interfaces have a cost of 4. Oh, what up, Paul? Sorry, I didn't see a message earlier, my brother. What up? Fast Ethernet ports have a cost of 19. So let's keep that in mind when we look at this topology here. All right. So let me scroll up. There we go. Perfect. All right. So switch 3 right here. Assuming all the default STP standards, which will become root. So we have 4, 3, 1. So this will become root. So your root. So that's root right there. All right. Now which one of, so remember, even though this is a straight through connection, this cost is 19 on this connection. All right. All right, so this cost would be 19. On the gigabit interface 0-1, this would be a cost of 4. All right. And then off of switch 1s to gigabit 0-3, this would be a cost of 4. All right. So with these two costs, with these costs adding up out of gigabit 0-1 interface, this gives us obviously the cost of 8. All right. Ooh, I actually did that quite well with my fingers. That was surprising. I've never done it that good. Even though that still looks horrible, that's the best I've ever done. All right. So what would happen is, again, even though this interface is going through SW1 and then out gigabit 0-3 on SW1, this port has a lower cost than the FAR02 port. So given this topology here, the gigabit 0-1 would become root port. All right. So it'd be gigabit 0-1 with the cost of 8. All right. All right. An STP topology with 3 switches has one link between each pair of switches. Which answer best describes the primary decision point as to which non-root switches have a designated port on the link between switches and which one does not? I got to read that one more time. That did not absorb into my brain. An STP topology with 3 switches has one link between each pair of switches. Okay. Which answer best describes the primary decision point as to which non-root switch has a designated port on the link between switches and which one does not? All right. The device with the highest bit bridge ID would become designated in the LS switches? No. The switches with the lowest root cost would become designated and all of the switches would block. Yes. Let me just read the rest. The switches with the lowest priority setting would become designated in all the switches. That's true, too. Switches with the highest cost, no. The device with the lowest bridge ID would always become designated in other switches. So I'm stuck. So the bridge ID, that can be obviously altered, but the switch with the lowest root cost would become designated. Switch with the lowest priority setting would become designated. I'm stuck between these two right here. I'm gonna go with this one. The switch with the lowest root cost would become designated and the other switches would block. That's the answer. Cool. So the switch with the lowest root. The only reason why I was stumbling on that was because we were reading how you can set the priority for a lower priority, so you can manipulate a switch to become root, and then apply that. You can also set it secondary as well. So that's where I was kind of just fumbling along with that terminology. All right, let's continue on. The exhibit shows a diagram of a small switch network. All switches use layer 2 switching and no layer 3 switching. The diagram identifies the root switch, switch 1, so switch 1, and all root ports and designated ports for VLAN 10. All switches have the spanning tree mode rapid PVST command configured. Okay, so it's using rapid PVST. The answers list ports that are neither root ports nor designated ports. Choose the answer that lists an RSTP port role that is meaningful for the port in that topology. Okay, we got to select three answers. Let's take a look. This one is heavy. This is heavy sauce right here. But let's take a look. Switch 3504 could become RSTP alternate port. I'm gonna skip that one for now. The switch 2 gigabit 0-2 can become alternate port. Backup port. Yes. So this could become backup. Because remember, when you think alternate, you think root. Alternate, you think root. When you think backup, you think access. Because access is end devices. So when we think backup ports, we have to think about, where is that going to? Is it going to an access point, which is going to an endpoint? Then yes, that would be backup. All right, but if something's going to a root bridge, to a root switch, we have to think alternate. Okay, so yes. So I'm gonna select yes for that, because it's going to a hub. A hub's a access device. All right. Switches 4 F02 F502 could become RSTP backup. So where's switches? Let me just erase my stuff here because now I can't see. The gigabit 0-2 out of the 502 could become, oh, where am I getting messed up on? Switch 2. The switch 2. Oh, wait, let me. Yes, that one is backup. And where's gigabit 0-2? I'm going to leave that one alone. Switch 4 is gigabit. 0-4 can become alternate. Alternate, yes, because it can become root. It can become a root port because it's going to a root bridge. So that's yes. And then switches 504 can become alternate, become backup. The only issue I'm seeing here with this, where I might get hung up, is even though 504, because it's stating 504 is either alternate or backup, this right here is definitely not an answer. But 504 because it's going through the access and it has a way to go out the access and possibly connect back into root, you know what I'm saying? Then possibly 504 possibly can become alternate. Let's go with alternate and see what happens, guys. All right. All right, we're good. All right. What is the name? What is the name of the new RSTP port state that replaces STP's disabled and blocking? So remember, that is discarding. All right, so discarding. All right. In the figure in VLAN 1, all switches have default STP settings, and all trunks are up and running at 100 megabytes per second. Which statements are true regarding the behavior of STP in this network for VLAN 1 after STP topology is stabilized? All right, let me read that one more time. In the figure in VLAN 1, all switches have the default STP settings. Cool. All trunks are up and running at 100 megabytes per second. Cool. What statements are true regarding the behavior of STP in the network for VLAN 1 after STP has been stabilized? So it's completed its convergence. All right. So select two answers. Let's look at the max. So switch 1 is root. Let's just write root. Switch 1 is root. Switch 1 will create hello messages regularly based on its hello timer. Yes, it will. S2 won't, because S2 is not root. Switch 4's 501 become designated port. Where's switch 4 and 501? No, 501 would be root port. You will be root port. Yeah, because they're both fast Ethernet. All right, switch 4s will forward a hello message out as 501 at a cost of 19. And then what's the last one? Switch 3's interface will be in the forwarding state, the 501's forwarding state. Yes, it will. Yes, it will. Because on switch 3, this would be root. Okay? Because it's going to root. All right, so this would be root port. So it would be in the forwarding state. All right, 502 on switch 3 could possibly be a designated port. You know what I'm saying? Let's go with these two right there. See what happens. I'm pretty confident, but let's just do it. All right, we're good. All right. Which of the following are functions provided by spanning tree protocol? All right, it prevents MAC table instability, prevents broadcast storm, prevents multiple copies of a single frame being forwarded. Nope. And places L3. Nope. Okay. Continue on. All right. The exhibit list. The exhibit list output for a switch with which two statements are true. All right. Let's look at the output real quick. So spanning tree VLAN 30. Cool. We got our VLAN 30. The priority. There's its MAC. It's root. So this switch is root. So S2 is root. Its hello timer is at the default with its max at the 10 times its default. So that gives it the 20-second timer. The bridge ID. All right. And yes, it's still saying that because it's root. Aging time 300 seconds. Very good. All its ports, because it's root, because this is the root switch, all of its ports are in the forwarding state. And they're all fast Ethernet ports, which gives them a cost of 19. All right. Got to choose two. There are 30 VLANs on the switch. There's only one VLAN. Well, there are 30 VLANs on the switch. Man, it's just the VLAN ID is 30. All designated ports are in the forwarding state. Yes. The bridge priority is lower than the default value of spanning tree. The switch is the root bridge for all VLANs on the switch. No. So yes, it is. Because if I remember clearly, the default is 30, 37 something. I'm going to go with that one. Because these just don't make sense. There are 30. I have no idea if there's 30 VLANs on that switch. And the switch is the root port for all the VLANs. I have no idea. I can't. It's not showing me all of it. So I'm just going to have to go with those two. Okay. We were right. All right. So 2 switches are connected by 4 fast Ethernet Ethernet trunks. 4 VLANs exist with members in each VLAN on each on each side of the 2 switches. The network engineer would like to have the switches treat all 4 trunks as a single 400 megabyte per second trunk with some of the traffic being forwarded over each of the links between the switches. Which of the following statements are true? So this is getting into load balancing and Ethernet channels, okay? All right. Which of the following statements are true of such configuration? The social banditry command will list the combined 4 links with the yes. For port, yes it will. So that's right. STP can be used. STP can be used to cause balancing over 3 or 4 trunks, blocking on one trunk to prevent loops. I'm not going to go with that one. It's not that one. The 4 trunks can be placed into the same Ethernet channel to achieve the goal. So let's just go with these 2 right here. All right, so we're good. All right. When you are configuring Ethernet channels between 2 switches, what are the 2 channel groups? Okay, what are the 2 channel group modes that you can configure if one end is using port aggregate protocol? So remember that's Cisco port aggregate protocol, and that is, oh boy, that is, oh boy. Desirable. What are the 2 desirable? Because remember, LACP. Man, what was LACP? Was it active auto? And PAG was desirable passive? Or was it desirable auto? Active auto. Let's just go with desirable passive. I might get this one wrong. Yep, see? I felt it. All right. I should have went with my gut instincts on that one, guys. My bad. All right. So, PAG is desirable auto, and then LACP is. So let's just read this. When you're using dynamic Ethernet channel protocol, port aggregate protocol, the 2 channel commands you can use is dynamic desirable auto, and when you are using Ethernet channel protocol LACP, the 2 modes you can use on each side is active and passive. So LACP is active passive. PAG is desirable auto. So when we think PAG, we think desirable auto. When we think LACP, we have to think passive active. PAG, desirable auto. LACP, passive active. PAG, desirable auto. LACP, passive active. Okay. We're going to have to stick that one in our memory banks. All right. Refer to the exhibit. Which statements are true about the input shown? Refer to the exhibit. Which statements are true about the input shown? So there's 3 answers we got to choose from. All right. So they're doing the Ethernet channel, port channel group, port channel 1, primarily aggregation, age of the port channel, port state, protocol. So the protocol is LACP. Okay. So they got two interfaces in there, gigabit 0-1 and gigabit 0-2. All right. One is set as passive, the other one is set as active. So we got to choose two answers. The port channel link is operational. The remote interface connection to 0 interface must be configured as active. The dynamic Ethernet channel protocol, no, it's not using, so we can eliminate this one out. Let's just scratch that one out for now. Scratch this one out. It's definitely not that one. The remote interface connected to on this one, it must be configured as passive. The port channel Ethernet group is non-operational. The dynamic protocol, so it's definitely that one. So let's definitely go with this one. And then, since it's using LACP, we're looking for active and passive, right? What did the exhibit show us? Active and passive. Go with non-active, non-operational. It must be set to active. All right. We got a couple of them wrong. What did we get wrong? So the link is operational. So the link was operational. Even though the interface, so that's what got me. Even though the interface on gigabit 0-1 is in the passive state and it needs to be configured, it states it needs to be configured to be in the active state. The port channel itself is in the operational command. All right, so we got that one wrong. All right. All right, let's continue on. Which spanning tree mode are IEEE standards? So MSStat, RSTP, and STP. All right, this is Cisco. So Cisco proprietary is spanning tree per VLAN spanning tree plus, and then rapid per VLAN spanning tree plus. Okay. The IEEE has the multiple spanning tree protocol, and then obviously the rapid spanning tree and the spanning tree protocol. All right. What is the default bridge priority on a Cisco switch? So this was where I got hung up last time, and it is. I knew it was hung up between these two. I want to say it's this one. So it's 32,768. 32,768. Default is 32,768. Default 32,768. I'm gonna plant that into my head now. All right. When configuring interfaces to be part of the same Ethernet channel, which of the following should you configure identically? So let me read that again. When configuring interfaces to be part of the same Ethernet channel, which of the following should you configure identically? When configuring interface to be part of the same Ethernet channel, which should be? All right, so we have to choose 4. So we want speed, access, duplex has to be the same. No. Access VLANs on and access ports. Yes. Allowed VLANs on a trunk. Addresses on a trunk. MAC addresses on. No. All right. Let's just go with those four. Speed. So the logic is the speed has to all be set at the same. The duplex has to be all set at the same. They all have to be all access ports. They all have to be access ports. They all have to be trunk ports. So if they're all access ports, they're access ports. If they're trunk ports, they're trunk ports. That's the logic. Let's see if, and that's why how it's phrasing that gets me confused, but that's the answer. All right. Oh, cool. We got it right. Let's see how we did, guys. Pretty stoked. That was a pretty long one, too. How'd we do? Woo! We passed! That was pretty good. What was that? 70? How many questions was that, guys? How many questions was that? I think it was 73 questions. It was 73 questions. We got a couple wrong. Some of the ones I got wrong were real dumb of me. Well, excuse me, I don't mean to say dumb. This one I definitely could have done better on. That I'm gonna beat myself up about that one. I know that one. And then where did we get hung up on? Chapter 7, we got 2 wrong. Chapter 8, we got 1 wrong. So chapter 7, configure and verify switch interfaces. Ooh, man, we got beat up on that one. So chapter 1, that was just, man, I fumbled that one hardcore. We did really, really well on up until we got to configuring and verify switch interfaces. We got a couple of those wrong. And we got 1 wrong there. And then we got 2 wrong on RSTP. All in all, we did, though, pretty well, though. We did pretty well. Just look at some, let's do a question review. Which one was this one? That's the dumb one I got. Yep. Oh, boy. Yeah, and it's a frame. I know. How do we go back now? Did it just undo everything I just did? Probably just did. Oh, no. And then, where else did we go wrong? So let's take a look back at this one now. Refer to the exhibit. So, this was the one where it was mismatched speeds, right? And not disconnected. Wait. Wait. Which one was this one? Refer to the exhibit to which are the operation potential reason for the interface's status to be shown. Status down. Kills me as I know. Yeah. I mean, I don't have the. I guess I don't have the subnet mask, so I can't say for sure. I can't even guess on that subnet. So that's one thing I can't guess. Disconnect the cable. Take a look at what else we got wrong. Refer to the diagram. Refer to the diagram if auto negotiate of the speed in the duplex between host A in the switch fails. What would be the resulting speed assuming sense failure in duplex? So this is where I got it wrong, and it reverts back to its slowest and half its duplex. So it'll be 10 and half, because 10, and then half its duplex would be half, right? So I can see where I got a couple of those wrong. To better understand where I fumbled where I kind of fumbled. Let's take a look at where else I fumbled. There's another one. What is true? Yeah. If a switch, yeah, that one I can't believe I got that wrong. If a switch is connected to that uses dynamic desirable, the switch enable would not trunk. Yeah, I get that. I understand that I got that wrong. How's this? I understand the answer now that I really think about it. Because you have those states, you have the actually optional states. With non-negotiate, that would pretty much say with the dynamic desirable. Dynamic desirable wants to trunk. Okay, it wants to trunk. But the non-negotiate will say, I'm not going to allow you to trunk, even though you're desiring to want to become a trunk. Non-negotiate is saying, I'm not going to negotiate the fact that we're going to trunk. All right. And that went back to that other question with asking us what other state would make a trunk become a trunk with the auto. So that would be the dynamic desirable. Dynamic desirable on one interface and then auto on the other, because auto is by default. Dynamic desirable will make that a trunk, okay? But if you had auto and auto, which is auto is by default, two autos won't trunk. So I guess I understand why I got that answer wrong. Here we go. We got two back-to-back wrong on these ones, so let's check these out. When you configure Ethernet channel between two switches, what are the two channel group modes that you can configure if one end is using pad? So this is where I got it. So what did I say? Don't tell me I already forgot. So, all right, active, passive, desirable, auto, so pad, desirable, auto, LACP is passive, active. Active, passive is LACP. Desirable, auto is patch. All right, I'm gonna plant that in my memory bank. Chink. And we got another one back to back on that one wrong. Which one was it? Nope. Doing it like this because if I go the other way, it'll actually show me the answer again. And I don't want to see the answer again. Even though I already saw the answer, I don't want to see the answer again. All right. Refer to the exhibit. Which statements are true about the input? Oh, okay. So this was one of the very last ones. And what it states, even though, yes, the interfaces are in separate Ethernet channel states determined by LACP, because remember, this is LACP, it's using passive active. Even though these states are different, the actual port channel would still be up. So the port channel would still be operational in that configuration. Ooh, we got somebody in chat. I hate when you get questions wrong when you know the answer. Yeah, yeah, exactly. That's why I keep beating myself up about A-dubs. That's what I keep beating myself up about. Is like when you know what the answer is, but sometimes it's like I'm fumbling over. It's like I fumble over the words on how they word it sometimes, and it's like I confuse myself, even though it's right in front of my face. It's like I'm confusing myself with how I'm interpreting the question. Again, I should know these answers because I've gone over this so many times now. But that's why we're doing this review, my brother. or my sister. That's why we're doing it. I'm gonna make sure this, like, before I take the CCNA cert, I'm gonna ensure that this is it's like I'm taking the hammer to my brain right now. I'm just implanting it into my head. All right. We went over the total. We went over the review. I feel pretty good about how we did. We went back. We kind of understood where we went wrong with some of them. What I kind of want to do now is let's jump over to Cisco Modeling Lab. Let's start with some simple stuff. Thank you very much, A-Dubs. I appreciate that, man. Let's start with some simple topology type stuff. We'll go through some of like the layer 2 switching stuff. And then we'll gradually get into some of the more complicated. No, well, not too much complicated, but what I'm saying is we'll get into like Ethernet channels and port channels and creating that topology again, just to go over the commands again and again and again. We'll run the show commands. And then again, what I want and what I've asked, what I'd like to give out to everybody is, if you guys, again, if you're interested in getting Cisco Packet Tracer downloaded, because tomorrow, I just want to spend another day in labs before we get into part 4, because part 4 of the CCNA cert, that's when we're going to start getting to IPv4 addressing and subnetting. Subnetting, I tell you, it will confuse. It confuses me still. It's something I still got to, I continue have to just dive into and continue to wrap my head around subnetting. And I want to ensure, though, when we pick back up on Monday, I don't want us to start subnetting, take the weekend off, pick back up on Monday, forget everything we did over the weekend, and then have to do it all over again on Monday. So that's why Monday I want to start fresh on subnetting. But tomorrow, though, I want to spend another day on labs. I also, what I could possibly do today, because I have a class tomorrow on setting up. It's a Linux class. Maybe we can do that, because I got my EXXI server up still. Maybe we could set up the VMs I'm gonna need for tomorrow's class, because I need 3 VMs booted up, because I gotta set up one. One's gonna be pretty much one VM's gonna be like the main server, where I'm gonna have it set up for DHCP, DNS, and then the class is gonna be going over how to positively configure a Linux machine to serve just to be a DHCP server, to be a DNS server, and stuff from there. I've gone over this. I've gone over DHCP a few times with Linux, with using Linux machines. I actually haven't spent no time setting up DNS on a Linux machine. So that's why I'm really interested in this class tomorrow. You down for some Linux stuff? All right. So that's kind of what we'll do. Let's take a step. Let's go into EXXI then. Let's just do that then. Cool. I'm down, Dubs. I'm down. Let's do it. All right. Let me get myself over to my other screen here, and we'll do that then. Woo! All right. So we're here. Actually, let me just log into my server real quick, guys. Spikes out all this real quick. I love that animation. I love it. I made this today in Adobe After Effects today. I love it. All right, enough of that. Let's get over here. All right. Alrighty. Let me let me close. Actually, I don't have to close that down. It's not sucking up too much. It's not eating up. I got enough space to do this setup then. What I want to do is this. Go to my data store. I want to see what images I actually have here. Because I think I deleted the other images, which is fine. All right. Let's go to new directory. I'm just going to be using the Ubuntu server. I'm just going to say, man, my spelling's crazy today. Just creating a directory on this real quick, guys, so I can upload the Ubuntu server image to it real quick. Shouldn't take too long. This server. All right. So, if you guys, so what I'm doing is I have the images on my actual host PC. I've already, I have a couple images. I got some Fedora images. Maybe I'll get the Fedora image on here too next. Because it shouldn't take too long to get these images up. I've already downloaded them. They're just on my actual host PC. I just need to upload them onto my EXXI server. So then we can make some new VMs real quick. And again, this is what I was gonna do this afterwards, but this would be fun for us to do together, because you guys really haven't seen too much of what I do on EXXI, and this would be good fun. This is cool. I love doing this stuff. Yeah, so EXXI, if you're not familiar with EXXI is if you've used Proxmox, it's very similar to Proxmox. Nearly almost the same. It does the same thing. So this is a layer 1 hypervisor, okay? Even though, yes, I have it, I'm hosting this off of my Windows machine. Well, what I'm doing is I'm using VMware Workstation Pro, which is a layer 2 hypervisor, all right, to then host EXXI. Even though again, you can pretty much boot. Well, you can bare metal. EXXI comes as a bare metal image, which means is you could take a straight clean computer, a laptop. There's even a way you can do it on a Raspberry Pi now. I don't really see too much doing it on a Raspberry Pi, just because you're gonna have to have additional resources on that Pi just to all right, let's do the Fedora server 2. I'm gonna have to boot. I'm gonna have to give this some more memory. It's fine. Fedora. Spelling everything wrong today. No, delete that. Delete this. I ain't getting goofy on them. I deleted it anyway, see? What was I saying? Yeah, so like I was saying, I don't find too much I wouldn't boot up. I mean, you can for fun, I guess, but I don't find too much value in booting up EXSI on a Raspberry Pi. Again, if you were giving it additional resources and stuff like that, yeah, go ahead. Feel free. You can do it. There's a possibility to do it. Um, but again, you gotta make sure you have enough RAM and everything, stuff like that in it to make these work. Because what you're doing is you're virtualizing other machines. Okay. Um, I have I've allocated pretty much almost nearly 3/4 of the resources off of my host PC to do what I can do on EXXI. All right. Um, and the only thing that I run off of VMware Workstation is EXXI. Um, because yeah, you could do everything that I'm doing just off VMware Workstation, but you get better, in my opinion. You get better. You can see things a lot clearer. You can manage, and you have visibility over everything. Like, we'll take a look at CPU usage. Um, you can alter these things. I just feel like it's so much easier, and it uses those resources so much better. So I give a pool to EXXI off of VMware, so it can't use any more than that pool that I give it. All right, because I know that I can afford to give it that pool. All right, if I start going ham on VMware, I might run into the instance where I might over allocate my actual host. Okay, but I know what I've given EXXI, my machine can handle that. All right, anything more, I might start running into issues. Obviously, we're streaming, we got a couple different programs all running all at the same time on my actual host. And the last thing I need to happen is, I run into a serious issue, something shuts down, and wham bam, thank you ma'am, we lose our stream because my host went down. So that's why I do a lot of my stuff just generally off of EXXI. Um, and that's just how things are going. Um, like with Windows just dropping their virtual desktop. I get a laugh out of that, but I honestly feel, I mean, that's the future. I feel I like that approach. Obviously, I get a laugh out of it because they're going to be probably charging people an arm and a leg, and people don't probably won't understand that they're going to be getting charged by probably the hour or something like that just to use that PC. I haven't really looked into it too much yet, but the thing is that's actually the future, and that's where everything is going. Where you won't, I'm not saying that you won't have a general PC in your house if you still value having a PC, but having things virtualized off of in the cloud, okay, that makes hacking and stuff like that so much harder for these, bad guys and bad people out there that want to destroy everything that good people have put together to make sure that we have communication the way we have communication these days. So by Microsoft taking this, and other companies have done it, by them taking that step towards virtualizing desktops, that's a step towards the right direction. Because say there was an instance where you had multiple host PCs. I'm talking on the range of millions of host PCs, probably billions of host PCs, billions of devices, all under the control of a bad virus hacker situation. That would be it happened in Europe some time ago, and I read something that my sister had given me an article on it. But imagine that happened in the U.S. That would really hurt a lot of things. That would hurt public things. That would hurt private things. The cost of it would be there would be a huge cost after that. And I'm gonna shut CML down. Just log out of it. I can get this up. Put you away just for now. Let's shut them down. Let's go back to my host real quick. I just want to look at what I got for storage. We're looking good. Hit that with a refresh. And everything went down, right? Yeah. Alright. We're good. Alright. Let's create a new VM. Next. This will be this gauge. I love all that. These random names I have in there. We're just gonna say Linux, and this will be. Woo! Thank you for the follow, Micah. Micah, I'm gonna mess up the last part, but I'm gonna say Micah Dia. Michael Dia. Micah Dia. Thank you for the follow. Appreciate that. All right. So that was Ubuntu. That's an Ubuntu image we're booting up. Yep. Next. All right. And this is going to be real light. All right. Let's just give this a little bit more RAM. I'll just keep it at 1 CPU. I'm not really too concerned. This is just a server image, so it should be light. We got to, though, come down here. Yep. And connect on power up. Yep. All right. Oh, wait, let me go back to this. No, it's fine. Everything's good. Yeah, that's good. All right. Let's finish that. What happened? Woo-hoo! Thank you for the follow. Who's that? Noreen MSB. Good looks. All right, let's go back. Let's see what happened. Something happened with that. Did not like what I did for some reason. That's fine. Fix that again. There it goes. I don't know why it got all funky on us the first time. There's that server. Let's power it on. Let's go over though. Let's create the Fedora machine. Well, that's gonna take a minute to do its thing. Let's create the Fedora server now. Fedora in here. I just use Red Hat. Just use Red Hat Enterprise Linux then. 2048, good, same thing, yep. Where's the Fedora server? There you are. Select you, good. All right. Let that do its thing. Back to you. And I'm going to open you up on your own tab. All right. English. Let's update with the new install. Let that do its thing. Let's come back over to my virtual machines. Let's go to the Fedora desktop now. Let's get the Fedora desktop fired up. Azure's pretty expensive. Yeah, Azure is pretty expensive. And what were you using for those network options? Did you have to pay for it? No. This is mine. This is all this is all me, man. I'm hosting all of this. I don't have to pay for it. I own this server. This is my own. This is my personal server that I host. So none of this stuff how's this? Yeah. So I already built this server. So everything I do on it, no cost. No cost. Done. Yep. And then, cool. And then no proxy. Yes, use the entire. That's cool. And everything else looks good. We're gonna name you. What will I name this one? Let's name this. Let's just gonna name it lab. Server is gonna be Ubuntu. If I can spell. Pick a username. We're just gonna say his name is lab, and then password. We're gonna give it my super password, super secret password. Super secret passwords in there. Yes, I want OpenSSH. Nothing else. Do you think? Then let's come over to this guy now. Let's get him up on his own. Not that. I want him on his own tab. Goes. Oh no. The question is where. The question is where answering for CCNA. Question. Oh, so I have a subscription. So good question. So I have a subscription for O'Reilly Media. I pay for a yearly subscription. Well, the 6 months, every 6 months I pay a subscription fee, and what that gives me access to A-dubs is it gives me access to the Pearson test program. And inside of that, so inside of O'Reilly Media, there's the certifications tabs, and in there, that's where you get access to all the Pearson. I mean, I have access to take all the AWS Pearson stuff, the Azure AWS Pearson stuff, everything that Pearson has to offer. I have full access to. I mean, I pay a good penny for that subscription, but I tell you what, it's worth it. I'm trying to get an affiliate with them so I can give out discounts and stuff like that for people who are on my channel and stuff like that. So hopefully that will come soon. All I can do is encourage people for now to stick around until I can get hooked up with them. But I pay for all this out of pocket right now. So good question though. All right. So English, United States. Yes. Continue. Let that do its thing. You're still doing your thing. I swear I got fat fingers tonight. Come on. You can do it. You can do it. Root SSH. Root SSH. My password's weak. Call you. Call you Lab. We'll call you Fedora. Fedora. That's all right. Fedora 1's coming up. This one's still doing its update. Very good. That started. All right. So we got a couple servers. We got a couple servers booting up right now. How's our host doing? The host with the most. Look at that. We're doing pretty good. We're almost maxed out on our storage capacity. I gotta ramp that up. That's cool for now. Come on, buddy. Finish. It must be a big updated soon right now. Yeah, but I got a couple other things on here. I got a GNS3 VM up here. Also with CML. You guys have seen CML a bunch of times. And then this right here, I got a Windows, even though I call it Cisco Packet Tracer, but I use this Windows VM when I use Cisco Packet Tracer because again, I don't want to be using my host. I don't want to be using my host when I'm on Cisco Packet Tracer. And this is that VM that you get that Windows. It's an OVF file that Windows allows to be used for educational purposes and learning purposes. It's cool, you know. So the monitoring, and this is what I really like about this, and this is where you get the value out of EXXI is when you can actually monitor what's actually going on within your VMs that you can see what's physically happening. Even though obviously all this is virtualized, but it's using resources. Actually, it's using real resources. And this is just showing what it's using in that moment. It's pretty neat. That's why I love using EXXI to do all this stuff with. Because I get to see what it's all doing. Oh yeah. While that's doing that, I might as well. I'm doing pretty good. I might as well just get my Ubuntu desktop up then. Let's get that booted up. Still pretty good. So what I keep referring to is my memory and CPU usage over here, guys. And you can tell I'm running now we're running a collective of 3 VMs right now while we're doing everything else. We're doing pretty good. Open a new tab. That's up. Very good. It's just about to finish. This thing is still doing its update. Let's go back to my host. The host with the most. Still doing pretty good. Good. Let's do an update on this too. Quick update on this. Yes, the Fedora server is going to be done before this thing's even done. Now, what I probably am going to do is we might create a bridge, we might create a virtual switch inside of EXXI and break these all off into it. Just because what we're going to be doing with DHCP, I don't want to mess with reboot, reboot. Fedora, you beat Ubuntu. Ubuntu booted up first. And Fedora wins the race. All right, sweet. Okay. Let's go into. We need Vim, don't we? Is Vim on here already? We don't have Vim. Sudo. Um. Just gotta install Vim real quick. I love Vim. Always got to have me some Vim. What are you doing? You broken? I broke my Ubuntu server. Good. So let's open up Bash LRS. Alias LA equals LS. Here's a nice little fedora thing for everybody too. All right. Reboot. Just have to reboot the. So let me log out of that. There it goes. Now it works. All right. So now we've made our first alias. Very good. So now we can use LA. Boom. That makes life easier. All right. Reboot. Finally. Go on. Boom. Look at that. The CPU usage dropped all the way back down. Beautiful. Come on. I thought Fedora only used DNF for their packages, managers now. Why you got Flex with the Vim text editor? I love Vim. That's why. I've been using Vim since I guess I started messing with Linux. So I just have now I just have a I don't know what it is. It's like I've stuck with Vim. I don't want to just have to learn something else. So that's why I stick with Vim. Um, People make fun of me on that one, but you can do so much with Vim. There's so many plugins with Vim. Um, Man, I even went out and got the actual the Vim book. What did I named you Ubuntu, didn't I? No, what did I name it? Wow. Okay. On you, very good. All right. Yeah. Like I said, Vim is pretty. Um, it is worth. I guess it it's worth learning. There's just so much you can do. Like I said, there's so many plugins. I mean, a text editor is a text editor is a text editor. Um, but the thing is, what I think, how I feel about it is Vim can be used on anything. You know, if I can get Linux to work on a switch watch, I could download Vim right to that, and Vim will work right on that switch watch, and I'll be able to manipulate files and do what I have to do. Yeah, Nano and all that usually common on most distributions. Um, but I again with you know I mean look at right out the gate. Let's just take a look at the bash file here. Um, so right out the gate, Vim already does a lot of like it already has a lot of the colors plugged in to it, so you could tell if you're making mistakes. You could tell if something is going to work or if something's not going to work. That's why I like Vim so much because I could see if I'm maybe not setting up the alias right. You know what I'm saying? Um, or yeah, it just again it makes sense. It has made sense for me to at least spend the time to learn to learn how to use it and stuff like that. All right, so we got that. Which one am I gonna make my DHCP server? Which one do I want to make my DHCP server? What do you want to install? Sure, install it. All right, let's make the Ubuntu because I believe the instructor is going to be using an Ubuntu image anyways for for this particular class. Just go to my server, little file I got. Server file. All right, let's go ahead. Steal you. All right, whatever. All right. P. We're just downloading the DHCP um, server software to it, and this is located in Etsy. DHCP and the DHCP config file. This is just it's an example file, but what we're gonna do tomorrow is we're gonna obviously we're gonna make our own DHCP file. This is a great example though on how to get your DHCP turn your DHCP server well at least get it up and running. I've done this in Cisco Modeling Lab. It's I actually have it. I should probably let me boot that up. How we doing on reserves? I'm doing good. Screw it. I'm gonna boot up Cisco Modeling Lab too at the same time. Virtual machine. You know what, then? Failed to extend swap file. Space left. Oh, okay, I see what it means. You know what? Then you're gonna get shut down, buddy. Alright. Shut you down. That should be good. Oh, it's giving me issues, huh? Huh. The first time that's ever happened. Space left on the device. 0. That's fine. Alright, since I already got that up then. You down then. New to me, but because I run out of. Is it because it's giving me an issue because of this? It might be. Huh. No. Now it's turning on. That was strange. That was the first time it's ever given me issues like that before. And it was saying the swap files. Um, Look at that again. Failed module, monitor loop power failed, module loop power on fail, on swap. So that was talking about. It could be because I'm giving. It's probably because of what I got. I'm allocating to Cisco Modern Lab itself because Cisco Modern Lab is pretty heavy. Um, I give Cisco Modern Lab, as you can tell, I give it 16 gigs, and I give it 6 actual CPUs. So because of that, that's probably why I was running into that issue. And I definitely gonna have to give this definitely more space. But let me what I want to show you though is I want to show you um uh, I want to show you a Linux lab that I created. Simulate this. This is actually this is a legit C's Ubuntu image, and this is going out to the real internet. Let me fire that up first. Fire this up first. Let that do its thing, and then get into the lab. Do something about the resources on that. Router. Might as well get this switch up too, because that's going to take a little bit to boot. These other ones are unmanaged switches. These are tiny, like Alpine Linux images, very small, very small images. This is, I believe it's I believe it's the Ubuntu server 20. It's that same Ubuntu image I was just had boot up as the server is the same image that this is running right here. Well, it's going to be running. The only reason why I'm not booting it up yet because so this is a DHCP server. So this is obviously it says DHCP server. I just named it DHCP server, but it's an Ubuntu image, and I downloaded DHCP to it. The router, this router though, what it's doing for me, because I hate statically addressing things. I just despise it with a passion, just because statically addressing, I tend to mess up everything, just because I fumble over default gateways and whatever else. So I have this acting as a default as a DHCP server for this DHCP server, but with the couple extra commands that I configured into the router, this DHCP server though is acting as a DHCP server for this VLAN. So this is VLAN 10, and then it's also acting as a DHCP server for this VLAN, and it's dynamically allocating addresses in the correct ranges, and also giving out the correct default gateway. It's all coming back to this router as the default gateway, and then everything is going out of this bridge connection. This is a NAT bridge connection that I have configured. That connection's, this right here is performing NAT. This route is performing NAT and PAT, so network address translation and port address translation. I have this router doing so it can route all these addresses because I have addresses in all different ranges, so it can all be routed out to this NAT bridge that's also doing NAT and PAT, and then it's all going out to my router, just so it can all be going out to the public internet. That switch should come up pretty quickly, and once that comes up, we'll be able to boot this up. Let's boot up that the DHCP server real quick. Like I said, Cisco Model Lab eats up a lot of resources, and that's probably why I didn't want to boot up. It's this thing. No, I should. Let me just make sure I can ping Google. Make sure I have DNS working too. All right, we're good. So, the reason why you see ping www.google.com, I just want to make sure I actually got DNS up and running. Let's do a sudo git update real quick. While it's doing that, let's get these up. Once these should come up real quick. These are just unmanaged switches here, and then we should be dynamically addressed in the proper range. This should update pretty fast though. I updated this like a day or two ago. There shouldn't be much for it to update. All right, let's get these up now. As you can tell, we actually got an address to us. Now let's make sure. Make sure DNS and everything else is working. Ping Google.com. And there you go. DNS is properly working. Let's finish that. Okay. Now that was addressed at what range was that? 10.0.10.100, so VLAN 10. All right, let's check this one out. Cool. That's in the 10 range right there. And perfect. So that's in the 10, that's in the 20 range, the 10. So that's in VLAN 20. So 10.0.20.100. Make sure. Cool. Google. And all right. And let me just take a look at the CD. Let's see, DHCP. And then we'll look at the actual config file that I made. This was the config file that I made. So I replaced the original DHCP file that comes when you download the DHCP server. And then I replaced it with this one right here. This is giving us the subnet. So I know I haven't showed you guys the IP address on the DHCP server. I'll show you that next. But this is obviously the subnet that the DHCP server is following in. And then I built in the two other networks, the 10.0 and 10, and then the 10.0 20, giving it all default routes, and then DNS default routes, and then DNS. And then on the router, now let's go to the router. And then I'll show you the configuration I got on the router. It always does these crazy trace backs. Let's just go monolith. Come on. There it goes. Come on. It's doing a lot of work. That's why it's taking a while. So here's the this is just giving out for the DHCP server right here. So this right here, that's the only thing I got built into the router. And then this is where some of the magic happens. Is you got IP, it's doing that, so it's doing that over there, and then some of the and then I have the obviously the one interface, and then I have the sub interfaces. Now the sub interfaces, this is where I have assigned the IP helper address. So by assigning the IP helper address, that's relaying those DHCP, those DORA messages, back and forth from these hosts to the DHCP server, and I have those built on all the sub interfaces that I have built in. So yeah, I'm looking forward to, like I said, I got a class tomorrow, going over building, again, it's going to be building DHCP and DNS servers in Linux. I'll follow up with you guys on I'll follow up with you guys on the information and stuff like that, and we'll go over once I go through that class and obviously get a little bit more experience with configuring Linux DHCP servers and that. We'll do some labbing. Maybe, yeah, because we'll be labbing tomorrow anyways, so maybe we'll do some more labbing on Linux, just primarily there, just going over strictly Linux stuff and stuff like that. I do want to though build a virtual switch on my server though, so I can place those VMs on that server, just because I don't want DHCP messing about with the other VMs that I got, because that could happen, and I don't want that to happen. So maybe we'll build a virtual bridge and whatnot. Maybe we'll see what happens, but yeah, guys. Like I said though, either way, if you're interested though, download Packet Tracer, guys. It's a free Packet Tracer is a free Cisco Packet Tracer is a free program. It's a great program, guys. It's a great program. It's a simulator, okay? So it's not an emulator. This is emulating everything. These things, there's extra cost and behind GNS3 and all that stuff. Even though GNS3 is free, you still need the images to make GNS3 work. Yeah, I love these tracebacks that this thing has. Woo! Look at that. That's just because it's not being I don't think I have the proper. Let me just shut it all down. I don't think I have enough. I don't think I'm giving the individual routers and stuff like that. I don't think I'm giving this router enough juice for its boost. Because let me see, what do I have in it? Void information. What would it tell me? Okay. So yeah, this is only getting 512 megabytes. But I probably bump that up to maybe I give it a gig. It'll probably work better. You know, it'll probably stop getting too messed up with that stuff. But yeah, guys, this has been a good day. We did a good review. We booted up the VMs that I'm gonna need for tomorrow's class. So I got the Fedora server rocking and ready to go. I got the Fedora server with DHCP already downloaded on it, and then obviously I got the desktop that I'm gonna do what I want to that. But then I'm gonna have to make a virtual. I gotta make a new switch on here, and then add a new port group so I can break off these. So I can break off these VMs on their own little virtual switch and stuff like that. So that'd be tomorrow's class that I'll be taking. Where's all that? Close this down. And close down. Let's just go more on that. But no, guys, this has been a really good time. I've had a blast today. Woo! Look at him go. Guys, I want to thank every single one of you guys for spending as much time as you guys had with me tonight. I value the time that you guys are giving me. I know that your time is extremely valuable. So from the bottom of my heart, guys, thank you very much. I love every single one of you guys. Thank you for Micah and Nordine for the follows tonight. I think those are the two follows. Did I get another follow, I think, today? Just see. Yeah, I think those are the two follows. I think I got one more, but I can't. Every time I go over the name, I keep messing it up. Yeah, those are the two follows. Thank you very much. And A-Dubs, thank you very much for your comments, man. I hope you got something out of this. I hope you're still with me. But you guys have a great night. Stay safe. Again, I'll see you guys here back tomorrow, 5 o'clock p.m. Eastern Standard Time, okay? 5 o'clock p.m. Eastern Standard Time. We'll be back here tomorrow doing some live and stuff like that. You guys can always catch these. If you guys want to catch these later, these will always be up on my Twitch page. You can also catch these on my YouTube channel as well, too, guys. These are always, I'm posting these go live and these get posted right on my YouTube page as well. So you can always catch this content over and over again if you guys need, okay? Other than that, guys, you guys have a great night. I love every single one of you, and thank you very much again.